Shall we get started? And other people can file in. Okay, welcome everybody. Thanks so much for joining. Feel free to introduce yourself in the chat, use the chat to ask questions, um, and that sort of thing. We'll have a discussion section at the end, and then there you'll be able to unmute and turn your cameras on. Um, So today we're here to talk about the new book, Exploring Complex Survey Data Analysis using R. And we're very lucky to be joined by the three co-authors of this book. So it should be a very interesting, exciting session. I, for one, am very excited. And so the agenda, just briefly, we'll go through some introduction, house rules, and then the main event, and then we'll have Q&A at the end. And again, in the Q&A, you'll be able to unmute. So your host for this evening, this is a joint session from Our Ladies Amsterdam and Our Ladies RTP, or Research Triangle. My name is Kylie Ainsley, and I'm based in Amsterdam, and I'm an organizer for Our Ladies Amsterdam. And I'm joined, my co-host is Sheila Saya. Did I get that right?
You got it. Yep.
Yeah. Sheila, if you'd like to introduce yourself.
Yeah. Hey, everyone. Thanks for joining. I'm a co-organizer for Our Ladies Research Triangle Park, RTP. We're based in Raleigh-Durham, North Carolina, so stateside. Thanks for joining.
Thanks, Sheila. Okay, and today, like I said, we are joined by Stephanie Zimmer, who's a senior research statistician at RTI International, Rebecca Powell, who's a director of data management and survey programming at Forest Marsh, and Isabella Velasquez, a senior product marketing manager at Posit. So we're very happy to have everyone. And before we start, just a few house rules. So Our Ladies is dedicated to providing a harassment-free experience for everyone. And so there is no tolerance for harassment in any form. And for more information, you can see the Our Ladies Code of Conduct. And I will post the link to that in the chat. And as I've said, due to time constraints, we'll save all questions until after the presentation. And so either post your questions in the chat and we'll call on you to ask them or ask them for you, or raise your hand during the discussion session and we'll call on you. And the authors have very generously offered to send two lucky participants, one in Europe and one in the US, a copy of the book. So you can enter to win by filling out the Google form. Again, I will put the link in the chat right now. So please enter to win. It's very generous of them, so very exciting. And then to stay up to date on additional meetups, you can look at the meetup pages for Our Ladies Amsterdam and Our Ladies RTP, or Our Ladies Amsterdam is also on Blue Sky, because we have other events in the works later this year. And we're always looking for speakers. So if there's a topic that you want to present, or you're preparing for a conference or a workshop and you want to have a test audience or whatever, please get in touch. We're always looking for speakers. All right, so that's it for me. I'm going to turn it over to our speakers.
Great. And I'm going to pop the link to the slides in the chat so you can go back if you wish at another time. And Rebecca's driving the slides. I think, Rebecca, you can head over. We're going to starting with the motivation of how we got here. So we're our users, all of us, and we work with survey data regularly. And we wanted to share knowledge, particularly with our users who aren't accurately analyzing survey data, and also bring in SAS, Sudan's data users who might not know about the R capabilities. And the surveyor package was developed using tidyverse style syntax. That's not developed by us, but it's a pretty cool package, and we wanted to spread the word about it. And so Rebecca and I did a short course in APOR in 2021. And then Isabella connected with us and said, maybe this would be a good book, because there's not much out there. And so here we are a few years later, with a book and excited to share this information with others. And so, yeah. So what's in the book? It's a high level overview of the survey process, is how we begin, just to get a lot of people aren't familiar with the process that helps you ground in how survey data is collected, and how it comes to be. Comparing the syntax, if you're familiar with dplyr, with syntax from surveyor package, how to read survey documentation, which is essential for being able to analyze it. And then we go into descriptive analysis, how to make publication ready tables, so that you can pretty get some pretty nice, beautiful tables for reports pretty easily, and figures and account for the errors. And we use a lot of real world data completely throughout the book, and really motivates realistic examples. So next slide. So, um, I don't know if people can raise hands or do a reaction. Who has analyzed survey data before? If you do like thumbs ups or stuff, I might be able to see it. And has seen weights on data sets, and wondered why they're there. Um, so, and why survey data is different. So why do these weights exist? So weights, and our book doesn't go into weighting, but it's necessary to know how to use them. So weights are constructed based on the probability of selecting whatever the unit is into the survey, and then they're often adjusted for different things, non-response and coverage. And using weights reduces the potential of bias in your analysis. Um, Weights are often adjusted by demographics and then variables likely correlated with outcomes. And so these weights, the big takeaway is that second bullet. It reduces potential of bias. And that's important. We don't want biased estimates. So next slide. So we just show a little example here of just a toy data set that's included with the survey package, of looking at, it has test scores from schools, and looking at an analysis of the change in test scores from some different counties over time, and whether we run a weighted or unweighted analysis can lead to different examples. For example, when you look at Mendocino County, I mean, one with the unweighted analysis, the difference in scores is positive, but with the weighted, it's negative. So you can end up with different results. And so the weights do become very important to use. A few years ago, an APOR presentation, actually, which is the American Association for Public Opinion Research, their conference, there was a paper presented about like how often people are not using weights. And it's pretty common to not use them and can lead to incorrect conclusions. And I just want to give some examples, like verbally, of some realistic examples of why weights are used. So, example, I used to work a lot in criminal justice statistics. I did surveys of inmates. Um, and I think this is probably true in most countries. There's a lot more male inmates than female inmates. Um, and so we oversample the female inmates. And we need to account for that in the weights. Otherwise, your sample has a lot more females proportionately than the population. So then at the back end, we adjust the weights so that it reflects the true population. That's just a very simple example. But let's go to the next slide of some examples of when weighting has gone wrong. This from For those in the US, you've probably seen this in your history book. In 1936, in the election, the papers based their headlines on polls and didn't wait for the actual results to come out. And one of the polls predicted that Dewey would beat Truman. That was not the case. many of you probably have never heard of Dewey, but you have heard of Truman. It's because usually we remember the winner. Um, and so they polled millions of people to predict who would win. And remember, this is 1936. Well, they used telephone directories and automobile registration lists, and those tended to be more wealthy individuals. And so their prediction was wrong. And if maybe they had waited or done some adjustment for this, it might have been correct. We don't know. But just weights are important, and so that's why it's important to use if you see that. And so we're going to go to the next slide. Another piece of important things that you might see in your survey documentation that you don't want to skip. You might see when you're reading survey documentation things about strata or PSU or clusters, or so those three might be in there, or something called replicate weights. And all of these are used to define to um, describe the design of the survey and correctly account for the standard errors and perform statistical tests. So it helps you get the correct standard errors. There's a lot of correlation going on. These are not usually simple random samples. And so the software allows you to correctly calculate your variance and covariance and your degrees of freedom. Um, and so you luckily you only have to specify this once for a given survey, and documentation will usually help you identify these elements. And our book goes into how to read this documentation. But really good documentation often has SAS, Sudan, or even R syntax to get you started with this. These are also important. So it's the weights plus this other piece really define what we're calling complex survey design. And now we're gonna really get into the code, but we wanted to provide this background for those that haven't used survey data before. So I'm gonna pass it off.
Cool. Thanks, Stephanie, and thanks, Rebecca, for working the slides. So you've heard an introduction to survey analysis in R, the motivation behind their book, and the importance of weighting. So now we'll talk about how you actually set up your workflow in R. To start, let's take a quick look at the key R packages used for survey analysis. So if you're new to R packages are collections of functions, data, and documentation that are bundled together to extend the capabilities of R beyond what is included in base R. And what you do is you install and load these packages to use the functions contained within these packages in your R projects. So first up is the survey package. So this package has been around since 2003, and it's really the backbone of survey analysis in R. Is a wide range of functionalities, including descriptive analysis, regression modeling, hypothesis testing. And what it does is it manages the complex survey weights. So it's extremely versatile, and it remains the core tool for survey analysis in R. Next, we have Surveyor, which was introduced in 2016. And you can think of Surveyor as a user-friendly wrapper around survey. So a wrapper simplifies the use of another tool by providing a more accessible interface, but it still relies on the original tool's functionality. So in this case, Surveyor takes advantage of tidyverse style syntax, which many R users find intuitive. And so if you're new to the tidyverse, it's a collection of packages designed to make working with data easier. And so Surveyor takes the tools from the tidyverse, like the pipe operator, which passes data objects from one function to the next, and to make it easy to understand and streamline the workflow. And if you're already familiar with tidyverse packages like dplyr for filtering and summarizing and arranging data, you'll see that Surveyor lets you use those familiar functions in the context of survey analysis. But it's important to note, Surveyor focuses on descriptive analysis, and it doesn't support more advanced survey modeling. Another tool that we want to mention is for creating tables. R has a very powerful package called GT. And this package allows you to build high quality customizable tables from your data. And while it's also very versatile, there's another package that enhances its capabilities for complex survey analysis called GT Summary. So it builds on GT and it specializes in creating polished publication-ready tables specifically for summary statistics and regression results and other things as well. And it works well with survey data, but there is one limitation. So GT summary currently cannot handle replicate weights, which we'll see in a bit. So just to wrap up, to set up your survey analysis in R, you'll be working with Survey, Surveyor, GT Summary, along with the Tidyverse and the GT packages. And then I just wanted to note too, this is not an exhaustive list of all the packages that work with survey data. There are many more packages for like imputation, complex weighting, and more. Thanks. Next, please. So here's an example of what the tidyverse syntax looks like. So mentioned earlier, dplyr is a tidyverse package for filtering, summarizing, arranging data, and more tasks. And so this pipeline uses the dplyr package to summarize the Townie data, which is an example data set. So this whole calculation, are contained within, oh, sorry. I want to mention in this pipeline, you may notice like the functions, like calculating the mean, are contained within what's called the summarize function. So in the first line, please press, thank you. We start with the Townie data set, and then we pass it to the next function using the pipe operator, which is that percentage sign, greater than sign, percentage sign. So you can think of the pipe as meaning and then. So we have the Townie data set, and then we group it by the status column, and then we, thank you. We summarize the land area KM2 column, and then we create two new variables, area mean, which calculates the average land area, and area median, which calculates the median land area. And they're all grouped by status. And you can see the output is going to be two variables, lower T signature, and then it's calculated the area mean and the area median. Next slide, please. Now, Surveyor, the process is very similar to dplyr, but there are some key differences to account for survey design objects. So just like dplyr, we use the pipe operator, and we take what's called a survey design object, which has a special class called table survey TBL underscore SVY. And then we are going to apply a function and pass the result to the next function, just like before. But instead of using simple functions like mean and median, we use special surveyor functions that account for the survey weights in the design objects. So in this example, API strat is a stratified random sample, and we've already created a survey design object called API strat underscore des. And then we group API strat des by the S type variable. And then we summarize it to calculate the mean and the median of API 00 while accounting for the survey design. So along with the statistic itself, you see the output at the bottom. Surveyor will also calculate the standard error. We can customize the summary to include other options like confidence intervals, the design effects, and various variance estimates based on what we need from the surveyor functions. But really the idea is that we use surveyor because the tidyverse syntax is easy to follow and understand. It might be very familiar to you. And so it makes this kind of like parallel sort of way of analyzing these data. Thank you. And next slide, please. So here's the general process for how to analyze and create estimates using Surveyor. So first you start off with a survey object with a table survey class that you create either using as survey design or as survey rep. And when you're creating this object, you're going to specify the important details that Stephanie mentioned earlier, like the weights, the strata, the clusters for your survey design, or you can use replicate weights if they are available. And so this step is absolutely essential for ensuring you get those appropriate weighted estimates, and standard errors we saw are really, really critical. And a lot of public use files are also providing this syntax to make it easier to work with their provided data. So, excuse me, after you create the survey object, you can use filter to create subpopulations from your data So you can focus on specific groups or segments within the data set. But note, it's very important to filter your data after the survey object and not on the original data frame. Then for survey analysis, you can use group by, like we saw earlier, to define the groups or domain for the analysis. So like grouping by region or age group or other variables. And then finally, within the summarize function, you can specify the variables you want to create. You can create different kinds of statistics like the means, the medians, like we saw, totals, proportions, quantiles, all sorts of things. And there is another option too. Instead of using summarize, you can also use what's called the cascade function to get the total row. So you can see a quick summary of your data without having to group it. And so the nice thing about this is the survey object you created can be used repeatedly for different analyses on the same data. So this is very helpful if you want to apply consistent survey design settings like your weights and your strata across different calculations without needing to redefine it each time. Next slide, please. So speaking of reusing that survey design object, the process for testing survey data with Surveyor is very similar to the descriptive analysis workflow. And again, you begin by creating this table survey object, then you use filter to create subpopulations for analysis, and then you can perform hypothesis testing with survey tests to compare means or proportions between groups or survey, goodness of fit, chi-squared for goodness of fit tests, and so on. And so these testing functions are designed to account for the survey design, and they'll provide you the correct standard errors and significance levels. Next slide, please. And then when you're ready to build the models with the survey data, again, the process is going to look very familiar, but there are going to be additional modeling functions that you could use, like survey GLM for linear and logistic regression models, and so on. So these modeling functions, just to reiterate, are also going to take into account the survey design. So now that we covered the setup of packages and the steps for descriptive analysis, testing, and modeling, let's look at some code and see how it all comes together in practice. I'll pass it to Rebecca. Thank you.
So now we get to the fun part of actually getting to code. So the first step is we have to load our packages and we have to load our data. And so those packages that we want to load this time around, so as Isabella pointed out, we want to load the survey package, the surveyor package. We're going to also load the GT package so you guys can see some summary tables today. And then we are also going to load in this Surveyor Explorer package, which is what we've created to go along with our book, which has some data set examples for us to work from. So one of the data sets we're going to be working with today is the REX data from 2020. So this is the Residential Energy Consumption Survey data. And this is national survey data that's collected in the US on various aspects of residential energy consumption. And so this slide here kind of has an overview of what's in the data. So we get information about urbanicity, the region, the state name, different housing types, the square footage, whether or not they've used AC, and so on and so forth. There's a whole bunch of stuff about different variables, which we'll get into. So now that we've had our raw data, so we're calling this our raw data, our Rex _ 2020 data set, we now have to create that design object. And so this is the first step that you have to do before you create anything with survey analysis. You need to make sure you set this up correctly. So we've talked a lot about the documentation for surveys. That is going to be very important for you as you kind of figure all of this out. So at a high level, there are two main functions that you can use to create your sampling design object. So the first one is the as survey design function. And this here is going to be used for most of your common sampling design types. So our stratified samples, our clustered designs. So these are kind of those beginning things that Stephanie talked about at the very beginning. If you have a stratified design, you're going to want to use this strata argument. Makes sense. Stratified strata, pretty simple, right? And indicate which variable holds that strata for you. It can also be, I think, multiple, like if there's a single variable, I think you can put that in there. If you're doing clustered sample, then you want to use the IDs argument. And this here you can put in both your primary sampling units and your secondary sampling units. So these are sometimes called PSUs and SSUs. And so you put this in as an array into this particular argument to specify which variables should be used for the clustering sample. Other arguments that are in here are the FPC. So this is often used for different types of smaller surveys, I guess, right? Trying to remember back to my math days. It'll tell you in the documentation whether or not there is a given FPC variable. And then we also have this nest indicator here, or argument here, where you can indicate whether or not your cluster IDs are nested within your strata. So if you have a super complex design where you have that nesting feature, you can change this variable to true, so that way you can account for that aspect. And then, of course, the most important one that everybody's talking about is weights. So you actually do need to specify the main analytic weight that's on the data set. And specify what that will be in here. So there's always going to be kind of a main analytic weight. This is usually the handling of the sampling, sometimes adding in the non-response aspects of the data and so on. But there's a single variable that's usually accounted for with this analytic weight. So you need to include that along with any other of those arguments that help specify what your sampling design is. The other function you're going to use if you have any replicate weights. So in this case, the function is called as survey rep. And you'll notice that there's some similar arguments in here, like the weights argument, but there's also a lot of different ones. So again, we want to make sure we always include that main analytic weight, but then we also have things like this rep weight function or argument in here. And so replicate weights are usually a string of like a series of different columns that indicate different replicates that occur in order to help you weight accurately of your data. And so these are often like a string, and we'll show you the example with Rex, but these are often, I'll start with a certain thing like RWGT and then a number, and it'll be like a series of numbers 1 through 60 that you'll incorporate into this replicate weights argument. We also have to specify what type of replicate weight. So there's balanced repeated replicates or BRR, Fay, jackknife, those JK ones, bootstrap, and so on. And then each of those has different parameters that need to be accounted for. So there are different arguments based off of the type of parameter you need. And again, a lot of this might not make sense to you, but it's all going to be in the documentation. So when you're looking up your survey data, it'll indicate that it's a BRR sample replicate weights with whatever parameters and whatever arguments are going to be needed for you to input here. So we have things like row, the scale, R scales, or MSE in here that can be incorporated. So let's actually look at how we would do this for the REX 2020. So the REX 2020 data has jackknife replicates. So we're going to be using that second one. So that's the as survey rep function. It has N weights is the weights, the main analytic weight. And then our replicate weights are N weight 1 through 60. And its type is jackknife, so we're doing JK1. And then it tells us in the documentation that the scale is 59 divided by 60, so we put that in there. Don't worry, again, don't need to fully understand it. You can just stick it right in there, it's great. And the documentation also tells us to set MSE equal to true. So these are kind of the main pieces that we need. And once we enter all of this in and we create our REX design object, then we can actually move forward with the rest of our survey analysis. So when you actually call that REX design object, though, you're not getting a pretty little tibble that you're used to seeing on your raw data. Instead, you're going to get, as Isabella pointed out, this survey table design type. And so it doesn't list out all of your raw data. Instead, it gives you the overview of what the structure is of your survey design. So it tells us here that we have an unstratified cluster, jackknife JK1 with 60 replicates and MSE variances. And then it lists out all of the weights that we put in there. So these are all of the replicate weights, the weights themselves. And then I'm just realizing it's not quite scrolling on this side here. And then we are also putting in all of the variables that are located in the data set itself. So it tells you kind of what all of those variables are. So now that we have our design object set up, let's get into the fun stuff of actually calculating some means. So the function that we're going to use is the survey_mean function. And so this is going to calculate our means while taking into account that survey design object that we just created. And so there's similar things that what you've probably seen from the regular mean argument or function rather. So we have our variable x that we're going to call in there, na.rm equals false or true. So whether or not we're including missing in there or not. But then we also have this variance type. So we can specify whether or not we want it to output the standard error, the confidence intervals, and so on. And then we can specify the level of those confidence intervals in the variance. So the default is 95. And then we can also use this for proportion. So we can specify whether or not proportion is true or false. So if we're just doing a mean, you want it to be false. And then there's information on what type of proportion method you want to use. So if you are using this for a proportion, you can specify the exact information on there. So if we wanted to estimate the average cost of electricity in the United States, this variable on the data set is called $EL, so dollar electric. And so we would then use our REX data set in here. And this is important because we want to make sure we use that REX data set, the REX_des object and not our raw data. So this is like the key difference, right? Don't use the raw data, use the design object that you created. And then what we're going to do is we're going to use the survey mean within that summarize function. So as we see before with the dplyr example that Isabella walked us through, you always use means within summarize. So survey mean within the summarize function. And so we're going to calculate the mean of $L. And then we also need to specify our variance output. So in this case, we're going to output both the standard error and the confidence interval for you guys to see. And this is what that output looks like. So the first column is the estimated average cost of electricity. So this is again going to be a national average across all of the people in our data set. The standard error is in the second column. So that's the _SE. And then we have the _LOW, so our low, and _UPP for our upper. And those are going to be our bounds of our confidence interval, are in the third and fourth columns. And this is a standard output of what you get from R. We will show you how to make the prettier tables later, but we just wanted you guys to see kind of what that output looked like. Now, this again is the national average. So how would we do this with the region? So let's say we wanted to figure out if the differences in spending across different regions in the US. And so to do this, we now add in the group by region function. So as we've mentioned before, you always need to make sure you do subgroups, so to subset or define our groups after creating your design objects. So it goes design objects, filter, and grouping, and then your actual means. So now that we've added in our group by region, we can output this data and we can now see that we have a new column in here that indicates what region this is for, but we still have our same output that we saw previously, these same other 4 columns. We just now have 1 row for each of those regions. So you can see kind of the differences across it. And so looking at this, you see that the South has a much higher number of cost of electric bill. So you might be wanting to know, hey, can we do some t-tests on this? Yes, you can. So that's the next step here. So we're going to now look at the t-test function. So in the survey package, it is called the SVY t-test. This is similar to the t-dot test function that's in base R. So you have the formula that you typically put in there for a t-dot test. And then you also have the data arguments. Now, in our case, it's not data that we're putting in, but instead we're putting the design in. And so one of the key things here is that this is actually out of the survey package and not the surveyor package. So we'll have to do a little fun stuff to make it fit in with the tidyverse here. So let's walk through an example here. So I'm going to pick on Stephanie. So Stephanie usually sets her home to 68 degrees at night during the summer. And she wants to know, is this different from the average household in the US? So we first want to look at let's look at the estimated average nighttime temperature in the US. So the variable is summer temp night. And we will output that here. And so we are setting it to mu. So our average is 71.4. And the standard error is 0.0397. Now, I do want to point out here that we have not actually specified the variance type in the survey mean function here. And so when you don't specify the variance type, it defaults to standard error. So just keep that in mind, that you don't have to always specify it if you know you always want the standard error. Okay, so now that we know that the average US household temperature is 71.4, we then want to test to see whether or not this is different from Stephanie's 68 degrees. So to do that and still use our piping mechanism here, I will talk you kind of through this. So the first part here, let's look at the formula. So that's going to be the first argument in our survey t-test function. So to do this, we want to do summer temp night minus 68 and then tilde 0. So we want to know if the difference between the two is equal to 0. So that's what that line means. The second piece here is the dot notation. So some of you might be very familiar with this if you're used to tidyverse and are more advanced on R users. But if you've never used the dot notation before, I'll just walk you through it real quick. So the idea is that the dot notation tells R where to pass the item on the left of the pipe into the item on the right of the pipe. So here we're taking our rex underscore des, and we're piping that into the survey t-test function, and we're putting that design object exactly where we tell it with that dot. So we're saying the rex underscore des, put it in this second argument called design. So the standard way that tidyverse works is that it takes whatever you're piping in, so what's on the left of the pipe, and puts it into the first argument of the function that's after the pipe. So that's kind of the standard. So if the first argument of your function is where your data is supposed to go, where your design object is supposed to go, then you're fine. You don't need to worry about the dot notation. But since the survey package doesn't talk nicely with tidyverse, we have to force it to tell it where to go. So that's what that dot represents. So when we output this, what we then see here is some lovely t-test output, which is, if you've done t-tests, not in the survey world, it looks very similar on this output, I think. And it's kind of ugly, but this here tells us that there is a difference. Our p-value is pretty small, our t-statistic is pretty high. And so it does seem that Stephanie keeps her house a lot colder in the summer than the rest of the US. So good job, Stephanie, or I don't know. One of the things I do want to point out here is that the mean estimate that you get at the bottom here, so this 3.367, that value is the difference between the two. So that's the difference between the national average and Stephanie's value, right? So we're not getting, this is why we output out that national average first, because when you do a difference like this, it's going to output the difference in the means and not the actual values for you to see. Okay, so that was a nice little one sample t-test. But now let's look at a two sample t-test. I bet a lot of you guys probably do this, trying to compare two different groups. So let's look to see if there's a significant difference in the electric bill for households with and without air conditioning. So again, we're going to look at the estimated average. So we'll do our survey mean here. And the variable we're going to be looking at is AC used. And we're again going back to that $EL, so that electric bill cost. And so we're grouping by our AC used, and then we are outputting our survey mean. So we can see that if they used AC, it seems to be higher than if they didn't use AC. So true is 1422, false is 1056. So now we want to know if this is actually any different. So to do that, our formula looks a little bit different than before. So we now have the $L on the left side of the tilde and AC used on the right. So the AC used is our grouping mechanism. So we're looking to see, is the difference in $L is $L different for the two different levels of the grouping variable? And so the output here now shows us that yes, there is a difference in the two. And we do see that difference in means again at the bottom of the output for our t-test. So we know that the difference between the two is $365. So that was a quick run through on those t-tests, but I'm now going to pass it back to Isabella to talk through how to make those outputs look a lot prettier.
Awesome. Thank you so much. All right, so once you have, created your design object, run these awesome analyses, run these fantastic t-tests and everything like that, you're going to be at the point where you want to present your results effectively. And so R has a wide range of packages for creating tables, such as cable and cable extra, DT, format table, flex table, reactable, go on and on. But in our book, we highlight the GT package, as mentioned earlier, because like Surveyor, it integrates well with tidyverse workflows because it uses pipes to format and style options onto your tables. And so, as mentioned earlier too, the GT package is a very robust ecosystem of extensions that make it even more flexible. And one of them is GT Summary, which was originally developed for clinical trials, and now it supports certain types of survey analysis. But as mentioned earlier, GT Summary does not currently work with replicate weights, and that is what Rex uses. So we won't be using GT Summary in our example, we'll be using GT. And in terms of how to create a table with GT, you start with your input data frame, like the one that we have seen earlier. And in this example, it's called data. And it's like pseudocode example, that's obviously not complete, but you take data, you pass it to GT, the GT function, and then from there you continue to add pipes to customize the formatting and style and make it easy to build a table that suits your needs. Next, please. So let's return to our Rex data set. Suppose we want to, again, estimate the average household electricity bill by region, and then we have stored those results in an object called Rex table. So if you imagine this table has rows for each region with columns that show the estimated average bill along with the lower and the upper confidence intervals. And now let's say you want to present this to your manager or your colleagues and you want to give them an easier way of kind of viewing this information. So we can then pipe Rex table into the GT function. So this is what the code looks like, and then the resulting table. So almost immediately you have something that, at least to me, is much more readable and easier to share. Okay, and next slide, please. So let's say that you want to add row labels, and these are called stub in GT. We can add that argument directly into the GT function. So this creates a clear separation between the row labels, in this case the regions, and the rest of the table. And next slide, please. In addition, there are other customizations that use separate functions, so not within GT itself. So for instance, if we want to add column labels for better readability, we can use this calls label function. And then next slide. Thank you. And then let's say we want to add a spanning label at the top of to kind of explain what the contents of the columns are. We could use this tab spanner function. And one more, please. The GT package also has helper functions for common formatting tasks. So for example, here we use format currency to format the values as currency. GT has other functions for handling decimals, percentages, and more. So it's really nice because it means that you don't have to say after you have run your analysis and have the output data frame, like you don't have to further edit that data frame in order to make it look the way that you want. You don't have to convert your numerics into something with a $ and a period and things like that. You can move all of that formatting directly into your GT table and do it there. And it also makes your code a lot easier to follow because you can kind of just see the layers of the table as you're building it. So, and this is a very small example. GT has a wide variety of enhancements. You could do things like add color, add footnotes, transform the text. You can merge columns and a lot more. And so you just pass your data frame to GT and you customize as you go. And with that, I'll pass it back to Stephanie.
Alrighty. So we're going to wrap it up so that we definitely have time for questions. Next slide, we've got some references, namely the surveyor package, the survey package, and then our book. And you might be wondering where you can find the book. And you can get print copies from a few different places. Routledge, which is the publisher. This cool thing that you can do your local bookstore, and it actually has a way for you to support your local bookstore, but still sort of order online. And then you could go to Amazon as well. We do have an online version as well. And we will open it up for Q&A. Yeah.
Amazing. Thank y'all. That was really, really good. I very much enjoyed it. I hope everyone else did. Sheila, are people able to unmute now? Okay, great. So there were a couple of questions in the chat, so we'll start there. Caroline, you had a question if you're available to unmute and ask it.
Yes, I mean, this one is not so much a what tool to use for weighting, but more around targets. What I've found in the past is that especially underrepresented gender minorities are usually either forcefully put into a male or female bucket to be able to weight, or just made up a percentage to be able to weight against. Like, I don't know what there are, like, if there are any new ways of going about it or how you've used something like this in the past. I struggle.
Yeah, for weighting purposes, yes, we're always yes, yeah, I won't spend too much time on this because it is a bit off topic, but it's a very good question. I'd love to talk to you another time about it. But we struggle with this at my work. I mean, often population totals just use sex. And so we're often calibrating to sex. And then there's the other issue that if we haven't purposely oversampled a certain minority group, we might not even be able to publish on the minority group for their own protection because of disclosure reasons. So that's a different issue, but related, that like we might not even be able to have that column on the data if there's not that many people participating in the survey from that minority group. We unfortunately suppress them. Actually, due to keeping their confidentiality. It's a double-edged sword. So if you want to learn about a group that is small, you have to purposefully oversample to be able to publish on it. Yeah, I don't know if anyone else has thoughts. Yeah.
I mean, I think, yeah, it's hard, especially like because at a national level, you're not going to get a lot of those rates. I think so finding smaller studies that are out there that are doing some of this work might help get you some of that benchmark information. But it's always an area like this is a place where you can then be the one to go out and try and get that gold standard for it too. So it does. It's frustrating, I think, on the analysis side, but it does lead to an opportunity for researchers to go out there and try to get that information and make it better.
Working on it.
We appreciate you.
Great. Thanks for that question, Caroline. Cora, you also had a question about some clarification. Are you able to unmute and ask? Maybe she's not here anymore. Okay, I don't think they're still here. But one of the questions was, you've said that you can find the inputs that you need in the survey documentation, and they're asking what that is specifically. And so basically, they're saying that no surveys that they've used have offered that much detail in the documentation. and that the characteristics of the sample often differ between uses of the survey tool. And so where do you typically find the information that go into that function that sets up the survey object?
Yeah. So I think that Cora had mentioned social psychology, yes. So they
Yes.
may be working with convenience surveys, which don't necessarily have this done to it. And so I think this is often people, yeah, this is a good, very good question. There's surveys that are done by uh, countries or other things in official statistics or some other groups that then have this weighting process done and are random samples. And so we have this information. It's either technical documentation or methodology. There's many names that these documentation can come over, and we cover that in the book. But sometimes when you're working with smaller things, they won't have this. And so then this actually doesn't apply. You're probably just going to do descriptive analyses and not be able, unless you want to somehow calculate your own weights, be able to do this. Yeah. Um,
So that
Isabella
actually
or
leads me
Rebecca,
into
yeah.
a
Yeah.
follow-up question that's related about what are some common pitfalls that users should avoid when using this workflow? I mean, and you've just mentioned one, if the information is lacking, then you really can't use these functions because you don't actually have the information to weight the data and set it up properly. Are there other things that you've encountered as you've written the book and explored different examples that people should be aware of?
Yeah.
Yeah.
Isabella, yeah.
Okay. Well, I was going to mention we do have a chapter that talks about successful survey analysis recommendations. Like as you're thinking about this, I mean, of course, and we also mentioned like in terms of documentation, like there is no standard. It could be any file format. It could be a PDF. It could be an Excel. It could be a Word document. In terms of what's actually contained, it differs like survey to survey and year to year. And so just but one of the big pieces of advice that we have is to be sure to read it, like never ever skip. Be sure to start with there. In terms of other kind of like pitfalls that folks might run into and how to like overcome them, there are things like from the analysis side, like being very careful about looking at variable types, and then also like starting with descriptive analysis to get a sense of what the data contains, and then also like thinking about what you see in terms of like, oh, why do I have an average region? Like that might not make sense. And just thinking like critically about the results and not taking them, kind of for granted. And yeah, those are a couple of examples.
I think another thing is thinking about why you might have missing data. Um, we talk a bit about missing data. Sometimes it's by design. For example, on the question asking about what temperature you set your house to, um, people that don't have a thermostat, that variable is missing because you can't set your temperature if you don't have a thermostat.
Mhm.
Um, so okay, so they're out of the denominator or whatever you might call it, right? But really thinking critically about your missing and whether you want to include missing as a category or not. Things like that is another thing that we dive into. And I would say in one of our earlier drafts, this chapter was called Pitfalls, but we decided to be more positive.
I guess I'm glass half empty. Um, oh, great. That's wonderful. And Elliot has just asked if there are any guides for survey design that you recommend. And I'm assuming that there are probably other links to other references in the book as well. Um,
Yeah, so the second chapter of our book actually goes into detail on kind of the overall survey process. So everything from, creating like the study design, the sampling methods, questionnaire design, kind of a very high level overview of all of this. So highly recommend at least checking that chapter out if you're interested in like the full like nuts and bolts aspect of it all. And we do have a lot of resources in there on places you can go to learn more because what we have in the book is very high level. But I will also say like knowing kind of that high level, like how everything works in terms of like how to create like what type of population are you looking for? What is the question actually asking? And how is it designed? Like all of those actually have massive implications for how you can analyze it. So another potential success story or slash pitfall that you could run into too there is not reading what the question wording is or not really understanding what population you are gathering data about. So knowing more about the whole survey process can really help you as an analyst to understand what it is you're trying to get out of that data.
Yeah, that's a really good point. I mean, honestly, that's not unique to survey data. It's really any data. Where did this come from?
Yeah.
What questions were asked? What's missing? Why is it missing? All that. So that's just sort of good data analysis basics. So we've got just a few minutes. And so another question was, why did you decide to write this book? I mean, what actually motivated you or told you that sort of was like, we need a book on this? Like what was that sort of motivating moment that got the three of you together and was like, let's write a book?
An email from Isabella? No. Um, um, so
I just
yes,
love adding work to people's plates. It's my favorite thing.
our spouses really appreciate it too. Um, and, um, um, I think for me, I think the documentation for the packages are pretty good. But I think adding this context to really help social scientists, that was kind of my goal for the audience, was a lot of social scientists. Um, and so making it accessible for those people that often can't use something like SAS or Sudan. Um, yeah. And putting not just the technical documentation that, like I said, they have good package documentation, but adding in a bit of narrative to really get people to think about what they're doing. Yeah.
Yeah, absolutely. And was perhaps a secondary objective to maybe convince people to migrate away from SAS or Sudan, join the R team.
Maybe, maybe, maybe. And we
Could
can
be
always
a,
show how cool we can get graphics and tables compared to those other things.
that is
That
true.
that is a huge level up.
Mhm.
Yeah.
Awesome. Well, we are basically out of time. So I just really want to thank you all again very much. This was absolutely wonderful. Thank you for giving us your time and making this presentation and writing this book. I don't know enough about survey analysis, and so I hope to learn a bit more.
And do we want to drop the
Thank
link
you.
one more time for
Oh,
entering the
yes,
drawing?
also, yes,
Yeah.
for those who haven't done so yet, please remember to fill out the Google form to enter to win a copy of the book. Please do that. And you get your very own physical book, because who doesn't like holding an actual book? So please sign up.
Thank you all.
Thank you for having us.
Yeah, thanks.
Stephanie, say Rebecca.
Bye, y'all.
Bye,
And come
everyone.
come to Durham for USR. That's
Yeah.
the last plug. All right. Bye, y'all.
Bye. Thank you.
See you.
Bye.
Did we stop the recording?
I did.
Okay.